Now let's do an example illustrating the basic 4 steps of node voltage analysis. Well, the first step is to select a reference node, which I did here. I selected the reference node, and we note that the reference node is 0 volts. I also labeled node voltage A, B, and C. And what we have is a circuit that is a bridge circuit, has two current sources, one IS1 and one IS2, and we have 4 resistors, R1, R2, and R3. I labeled the currents as shown for R1, so I1 goes in this direction, and I also noted the polarities once I select the direction of the current. So here I2 is going downward, so the polarities is on the top and the negative polarity is at the bottom. Same thing with I3 and I4 as shown. I will do the KCL equations for nodes A, B, and C. So for node A, our incoming currents is IO minus I1 minus I2 is equal to 0. So our incoming current is IO and our outgoing current is I1 and I2. Next, for node B, our incoming current is I1 plus I5, and our outgoing current is minus I3. For node C, our incoming current is I2, and our outgoing current is I5 and I4. Minus I4 and minus I5. So that's the KCL equations associated with step 2. Now a third step involves expressing our currents in terms of the unknown node voltages. So we'll go through the element equations and the input signal sources. So for I0, I1, I2, I3, I4, and then I5. Alright, for IO, that's just simply IS1. And for IS2, and I5 is just IS2. Okay, now for our element equations, we use Ohm's law since we're dealing with resistors. So for I1 is G1 in terms of the node voltage. So it's VA minus VB, VA minus VB. For I2, we have VA minus VC, so it's G2, VA minus VC. Now I3 is right here, so it's VB minus 0, so it's G3, VB minus 0. And then I4 is just VC minus 0. So it's G4 VC minus 0. Okay, that concludes that step 3. And then our next step is to take these currents expressed in terms of the unknown voltages or current sources and put it in our step 2. Okay, step 4 involves taking our element equations found in step 3 and substituting into step 2 for our KCL equations. So we'll start off with node A, then B, then C, and just substitute our unknown node voltages and our known sources, input current sources, into step 2. Alright, so node A, then node B, and then node C. So in node A we got I0. Now we'll put I0 in the right side here, we'll put our independent sources on the other side. So that's just IS1. And then putting I1 and I2 on the other side makes them positive. So we just substitute G1 times VA minus VB for I1, and then I2 is just plus G2 VA minus VC. So all we did was just substitute in our node equations. Next, for node B, we have I1 plus I5 minus I3. So substituting for I1, we have G1 again, VA minus VB, and then we have I5, which is IS2, putting it in the other side, that's IS2 with a negative, and then we have minus I3, which is just minus G3 VB. And then finally, at node C, we have I2 minus I4 minus I5 equals 0. I5, we saw that that's a source, so we'll put positive IS2 here. So now we're left with I2 minus I4. I2 is simply G2 VA minus VC, and then I4 is minus G4 and VC. So now that we completed step 4, we're going to finish it off and write down in terms of our standard form. Now we're going to take our equations in step 4 and put it in standard form, namely putting the unknown voltages along the diagonal, VA, VB, and VC, to be positive, and then the off diagonal terms to be negative. And I'll show you what I mean. So we'll collect at node A, voltages VA, node voltage VA, G1, let me clean this up. So G1 plus G2 times VA minus G1 VB minus G2 VC equal to IS1. Now to clean up node B, we multiply the equation associated with node B by -1, and we'll see why, because that was going to give us a minus G1 VA plus G1 plus G3 VB is equal to IS2. Okay, and then finally, and we can put a 0 here, plus 0 VC, just to show that we can put it in matrix form. Then we get minus G2 VA plus 0, I'll just put VB, plus G2 plus G4 VC is equal to minus IS2, where we multiplied node C in here in this equation associated with node C by -1. So this is what we mean by standard form, in which along the diagonal it's positive, off diagonal terms are negative or 0. And then everything on the right side of this equation is associated with input signal sources associated with those nodes.